more critical findings are, the higher is the final issue. The basic idea in the end, according to issues. And threats have the same structure as issues. And if the detections are critical enough, then it creates threat. So threat is the thing which you want to focus in the end. So I want to show you the main capabilities what this offers. So the idea is, let's quickly jump into the overview. The idea is to create high-level views on really risky and critical problems in the cloud infrastructure. And this is these are the issues here in the overview. So you have issues when you have multiple sources of findings, of vulnerability findings. So if you, for example, have a CVE somewhere, for example, here in the for this issue, you have here a CVE. It's also external accessible from the internet, and also it is validated by the attack surface scanner. So we have at least 3 like problem types here identified. Then it becomes a vulnerability, an issue, and not only a vulnerability. Per se, it could be only a vulnerability, but if many different stuff come together, so it's a risk-based approach in the end, which includes context of the problems and creates context. And this context is created within this by the security graph, which we see here. View on security graph. So if we deep dive on the security graph, we see here the context of this issue. And in that case, we have the context, we have internet connectivity available. So it's an internet exposed endpoint with a critical CVE. The CVE is also validated by the external scanner. And here we see also which systems are in behind. So yeah, and this context is enriching the security graph and helps to manage too many thousands of vulnerability findings. This is the idea of issues. So you have many sources of vulnerabilities, not only CVEs, what you know from the typical vulnerability management systems, like these are vulnerability findings. Like here are all the different known vulnerabilities, known CVEs. And then you have also on the other side cloud configuration findings. These are typically like what is known by typical cloud security posture management solutions. So which scans for cloud configurations according best practices, like the well-known CIS benchmarks. And then we have also host configuration findings, so also configuration, but on host systems like Linux host. You have like unhardened, insecure Linux system. And so, for example, unauthorized file access attempts are collected. So these are more like host findings. And if many or enough findings come together, flows together in the security graph, and then WIS decides, okay, let's create an issue. And also the higher and the more stuff, insecure stuff come together, the higher the critical issue is. The issue is up to critical issues. By the way, there is a so-called zero critical club in WIS. So this means companies who are deployed their cloud infrastructure and get rid of all critical issues they comes into the zero critical club. So this is like the gamification part of this. But yeah, in the end, this is the idea. You have different sources of vulnerabilities. As you see here, for example, vulnerability findings, we have like 30,000, maybe something like that. Cloud configurations, also a few thousand. Host configuration findings. Yeah, where is the number? 538, so also enough. And also data findings, secret findings. So for example, if we have like somewhere access keys flying around or private personal information, GDPR-relevant information, credit card information. So it also detects such stuff. And the more critical the findings are, the higher is the final issue. This is the basic idea in the end, according to issues. And these are the graph control issues. And the same idea is within, so issues is for protection, right? So in the end, you want to be secure and resilient. But as 100% security is not possible, you have also to detect possible attacks. And this is where with defend came in. So this is here, like here, the with defend. So in issues, we have typically with cloud, mainly is working, and with threats, we have with defend. So in with defend, detects attacks. So it's not only prevention, but also detection and reaction. So this is with defend is for detection and reaction on threats. And threats have the same idea and structure as issues. It has detections. This is what we know with issues with findings. So these are different sources of detections. And if the detections are critical enough, then it creates a threat. So threat is the thing which you want to focus in the end. You can also have like few thousand detections overall. They are here somewhere. Yeah, here there are the detections. Here 3,000 detections overall about, so many different detections. But you want to focus on the detections which are really relevant, and these are the threats. So, for example, SSH connection with a malicious IP. Okay, SSH connection is not the real thing, right? Maybe it's okay, but if it's with a malicious IP, and this IP seems to be in the blacklist somewhere at WIS, so South Korea. Okay, so with this IP from South Korea, which is typically not involved with our instance, and is also on a blacklist, so it's a malicious IP. This is a very important thing here. Then we should really focus on it. Maybe it's like part of the bot network, right? So then we want to investigate here. And for investigation, this offers also AI. So we can see here what's happens here. And this is like produced then by the AI. So we see this EC2 instance established an SSH connection to this IP address from South Korea. And yeah, last at least of about 5 minutes, transferred 100 kilobyte in total. And this is all what we saw here. So we saw here at least 3 events. Oh no, 72 triggering events. Yeah, so this is all what we saw here. And yeah, this is the threats. So we have in the end the issues on the one side, high-level issues to look at. And this is what we have really to focus on, threats and issues. And later we can manage also all the different other findings, what's necessary. And the types of findings which are covered are completely from code to cloud. So it means with code, for example, if we go here to SAST findings, we see here the symbol with code. This is like managed and produced by with code. So it means we can monitor our development projects, not only when the projects are deployed and running, which we identify then by with cloud, but during the coding. If we integrate our version control system like GitLab, GitHub, and so on. So we deploy our version control system, and then we see our static source code analysis findings here. And yeah, this is the idea here between the findings and the comparison between different WIS products. So you can also like see here your scans, so where you have already a visibility, and if you are compliant or not. So you can have like your CI/CD pipelines managed, and see, okay, do you have some issues there? If yes, okay, passed. If no issues passed, if yes, then you want to be warned, or you even want to say, okay, let's block this build. Okay, here we have no rules, but you could also go and block it, the CI, the pipeline. So you not deploy if the criticality is too high, for example. So this is what you can do. Also, you have here the full inventory of your cloud. So it means you have, for example, the visibility on the used technologies, what you have, or the visibility on the Kubernetes clusters. You can create and see the SBOM, also very relevant according to Cyber Resilience Act required to create SBOMs. You can also export the SBOM. And yeah, so this is the full view from the development view, SBOM, vulnerability findings in the dependencies, what you have, and then also once you build. Also, a very important thing is, in my opinion, the threat intel center. So here you see the most relevant actual vulnerabilities, 0 days, ongoing attacks, hacker groups, maybe which are exploiting some specific vulnerabilities. So this is the classic threat intelligence. And here you see, for example, scatter spider, malware, 0 days. So you can look for specific things, or you just look what's the newest event here. Here from yesterday, for example, and at any vulnerability, you can directly see if you are affected or not. 0, okay, not affected. We can also include here Mika, so the AI. Okay, it's not affected. We anyway know already because this is here 0. I think, yeah. So Mika should say the same. No vulnerabilities found. Okay, so check. Makes sense. Next one. WatchGuard Firebox. Also not, also not, also not. Okay, here we have something in Apache Tika. So maybe we can check this. Yeah, directly we see here 2 instances we are affected. Let's quickly go back. to look with Mika again. So, okay, what's going on here? Here we should be affected. So here is also the S-bomb analyzed. So the software bill of materials. And let's see. So we should have some results here, as we see two findings occurred. Yeah, and here we are. Again, the same result. So 2 instances are running version 1.2.2, which seems to be relevant here. And if we then go to these 2 critical, in that case, these are vulnerabilities and are critical. Here we also see the relevant projects. And this is a very important thing. So which projects are affected? This is a part of the democratization process, which is critical to run within a company. Because in a big company, you maybe have 10 or 20 or 50 development teams, different projects here and there, and you have to structure it a little bit. Because if you have only like in your CISO department, security department, working only with this, maybe you can't assess every finding properly because you're not. I mean, here it's clear, it's a CVE 1.2 to update it, but you also don't know what happens if you update. Maybe you have some dependencies which will not work, right? So this is where you have to involve your teams, and you can then go and see, okay, in which teams I can approach, which teams can fix this, and also what version we need to fix this. Fixing date is 5th December. Recommended version is also here. Nice. Here we see the pipeline. So we see here the code repository where the vulnerability came from, the deployment. So Terraform, and then the virtual machine finally, where it's deployed. Redis Bitbucket. Nice. So okay, we see here everything, and yeah, can now work and remediate accordingly. All right, and regarding the project, so here we have we can choose the project to focus our view on a specific project, and the projects are completely freely designable. So you can create your project with specific resources, specific subscriptions which you want to include. So you can design your projects as you want. So here, for example, our projects here, we can see them. So we have the legal department, so design based on departments, but this is what you can do completely yourself. You have the legal department. There is, for example, this MongoDB project included. So it's an application. With Terraform, it's created. You can also then see, okay, what else? Code parent. So this is also Terraform managed. So you can manage your resources in projects. And with this approach, then include different teams within your projects. Right? So you can say, okay, this team has access the HR, okay, HR will not access, but let's say like someone who is responsible for MongoDB, they will have access to the MongoDB project here in this and can manage the MongoDB findings and detections and help the security team to investigate here. Because, for example, if you look in the cloud configuration issues, but let's say like for all projects first. Yeah, cloud configuration findings, even better. Yeah, here, for example, we have unrestricted SSH access is allowed. So we don't know maybe in the security team if it's worked as intended or implemented as intended, or it's really a problem here. So can we mitigate this? Can we restrict this? This is, can be assessed by the right responsible guys and also implement. And so we can have some recommendations here to implement, so how to remediate. So this is, maybe you can also generate, like this is standard remediation step, but we can also like ask AI to create remediation steps. For example, we want to mitigate this. So this is VPC SSH access, so cloud configuration, right, in the AWS cloud. AWS. So this is here the VPC finding. And we can now fix this by the AWS CLI or via the console. Or if we are using Terraform, we can also create Terraform script or create a Python script, depending on what you want. Let's, for example, go to Terraform. So this now creates the right Terraform code to fix the vulnerability. So this is quite cool. So supports you with quick remediation steps. And this is why it's very important, like to not only like the classic vulnerability management works, so that you have your finding and you just create a ticket, put the finding description in the ticket and go. But you really investigate here within this platform, because you have much better visibility if the teams are working with this to remediate this stuff, because that you not only like copy. I mean, I could also, as a security guy, I could say, okay, just copy the stuff here, copy the results, and put it in a ticket somewhere and forget. But I mean, it's much better if the responsible guys see directly on the platform. This is a democratization process. So we democratize with, involve different teams to work really with this and work on the issues, work on the threats. So we can also, for example, here within the threats, directly involve our SOC team. So here, this threat management, I would say, we include our SOC. So the SOC can work with this, work on the threats. So here is some SSH connections with malicious IPs. Here we have inactive account. Also very interesting, right? So an inactive account has assumed an IAM role. Yeah, so okay, why? Right, and then we can, for example, say, okay, we plan an action here. So this is like here the planned action by SecOps AI agent. And we can also modify the status. So we can say it's closed if we investigate it and everything is okay. Or we say, okay, still pending. We can create a ticket. We can contact with cyber incident response team. So we get support by this. Otherwise, we can, run an action, for example, send an email. We can assign here to a guy who is responsible for this. which we maybe see based on the projects, on the people who are working with the resources. And yeah, so with that approach, see what happens and work on the investigations. Here we see also the investigation graph. Well, so what happens? So EIM role created, some policies matched here the occurrence of different events. So these are the detections in the end. All right, what else? Yeah, so what also a very important thing is, so right now we had the full view on all aspects of if I manage all the security stuff. But for example, I can also have a focused view on for example, as I'm in the SOC team, I have to focus more on the threat detection response stuff. So I would say for a SOC guy, if we democratize and involve our SOC guys here, we can say, okay, here this lands. This is really the most important things. We can see here the threats. So what events? So we have 5 critical events. Okay, let's focus on the 5 critical events. We can also see as a SOC, or let's say like a CM, a SOC architect, you want to see, okay, are you really ready? Incident readiness. So have you already configured your incident management accordingly? So have you, for example, enabled logs, enabled, for example, here application gateway diagnostics and firewall logging? So like, are you really ready to detect everything what you need to detect? So this is a readiness. So it also shows how mature your configuration is in accordance to threat detection. Or are you like a little bit blind in your cloud infrastructure? So this is also what you have, like your readiness for investigations. And then you have all the detections. This is like the big number, which you can't focus really. Your threat intel with focus on detections. So you have the upcoming attacks. So for example, here we had this XXC vulnerability, right? So here I can say, not if I'm affected. I mean, here we know already, but did we had some attacks here? This is maybe more interesting, right? So for the SOC team, because the SOC team will not fix this. I mean, the fixing it will go to the different teams, but the SOC team has to investigate if some attacks occurred. So, for example, we can say like, have we had some detections on this vulnerability, right? And then Mika queries for you the security graph checks. Okay, let's check if we have also some detections here, some possible attacks, which indicates that we maybe are compromised. So it's more critical, right? So you have to really think about not only we are vulnerable, but are we maybe compromised? So do we need some forensics? And no, so no threats triggered. Nice. Then we can move forward. Yeah, this is like this lens for SOC. We have also other lenses, classic vulnerability management, attack surface management. This is like the attack external scanner here from WIS. So it means what we see here. It's validated also. So it's scanned externally. For example, here, default credentials, also nice. In our cloud infrastructure, are there some default credentials running? I mean, this is like an absolute no-go, right? So default credentials, external exposed, catastrophic. This is like low-hanging fruit. I mean, this is typically you don't have it too long. Admin default credentials are here valid, right? And this is what the external scanner do. And this is yeah, you see here this lens. You can, for example, also have a lens for the dev guys. If you go the democratization process with the development, so you see here all the development stuff. You see like your software composition analysis findings, so like CVEs, static source code analysis findings, like maybe some CI/CD pipelines problems, SDL posture, secret findings. Maybe you have some secrets, API keys exposed somewhere. This is what you can see within your code repositories which you deployed. You can see here also your scans, if they're passed or not. Also, again, here the threat intel center. So whether your CI/CD pipelines are affected by the upcoming 0 days here, or not upcoming, but latest 0 days and vulnerabilities. So, because otherwise you would only see it if you're deployed, right? The vulnerabilities. But if you scan before in your CI/CD pipeline, then you see this also if you are going to be affected if you would deploy it. And then you can also have your security graph. You have the inventory also. So you see your developers with different roles. You have also the visibility who has admin access, involved in which issues. Yeah, you have your SPOM also here in that view. Yeah, so quite nice different lenses what you can use here. Also for the pure compliance management, so classic CSPM topic, you can just go to the compliance view and see if you are hardened according best practices like CIS benchmarks and so on and so forth. So this is in the compliance view. For example, I can say, okay, cloud configuration. So all the cloud configuration findings and yeah, so CIS benchmarks, for example, you can check here. Compliance reports. Okay, you can create some. Here, framework catalog. So I guess here are, for example, the CIS should be available. Yeah, here it is, CIS benchmarks. So for example, we can, if we have an Alibaba deployment or AKS, also not bad, AWS, we can say, okay, let's check according the latest AWS CIS benchmark and see if we have a rule there. Okay, let's enable them. We can enable, and yeah. So I have no permissions, but we can enable them. Also, we can duplicate and make our own forks of the standards. And yeah, so check centrally according configurations. Also, if you have like some AI stuff, like AI solutions which we are using, we see our different AI resources here. Okay, so here we have nothing in that demo environment, but we would see here our AI agents. Yeah, but here we have some models, some chatbots. We have here GPT AI model. So we have here our AI models inventorized in the project and the subscription with washers. AI pipelines, AI data stores. So in the end, you have a quite good visibility here. And also you can directly look in your in the findings, but with AI focus. So okay, we have here some findings in OLAMA, critical severity. Okay, let's check what's that. Or on the MCP code library Python. or we can directly, let's quickly go to the dashboard, so top level view. So what is the most critical issue here in general in our AI stuff? Internet-facing VM with initial access vulnerabilities can access the bucket, and for AWS Bedrock custom model AI training, yeah, so there are some access vulnerabilities in there. So I guess some different configuration issues behind on the one side, initial access vulnerability. And yeah, okay, let's check what we can do. So here we see also how it's related here with our cloud to code. So from in which code repository, which deployment, on which machine this is there, and we have overall 24 vulnerabilities. So it's a summer. So it's an issue. Due to that, it's an issue, right? So we have 24 vulnerabilities overall, and yeah, have now to look what exactly we have to do. So it's a Terraform script here. Yeah, and now we can help get support. For example, here with Mika AI to investigate, to see how to mitigate. So here mitigation, let's check. Select how to remediate. Okay, we can mitigate, for example, the vulnerability itself or the external exposure. Let's say like the vulnerability itself. Okay, let's go via the SSM agent, and yeah, here you see all the vulnerabilities. Okay, so we want to fix them on all machines. Okay, let's go on. And now how to fix again? Let's do this via, this time via AWS CLI. Okay, yeah, here it is, the AWS command, which we can drop directly via the command line interface, and then it's fixed. Yeah, here we see it's doing some third-party Kung Fu and fixing the libraries, more or less. Yeah. Bitbucket update and so on and so forth. Java library updates. And yeah, you see here the different steps what you need to perform. Nice. Yeah, this I would say in a short, it's enough.